Okay, so I'm gonna do most of the multiple choice, and then all four of the last ones, the FRQs. And then a lot of ones I'm not gonna do in the calculator, just because we've done it so much and there's not really much left to do. But I'll do a couple in the calculator where, um, yeah, maybe ones that are different or maybe just random ones, I guess. Okay, so first multiple choice, they say radio talk show host with a large audience, and that the fact that they say a large audience, matters for the especially for the 10% condition. Large audience is interested in the proportion P of adults in his listening area who think the drinking age should be lowered to 18. To find this out, he poses the following question to his listeners. Do you think that the drinking age should be reduced to 18 in light of the fact that 18-year-olds are eligible for military service? He asks listeners to go to his website and vote yes if they agree the drinking age should be lowered to no, or should be lowered, and no if not. Okay, of the 100 people who voted, 70 answered yes. Which of the following conditions are violated? Okay, so just go one by one. All right, so the 100 people that voted were just people that voluntarily responded, um, somehow through one of his audience members. So definitely not random. Those 100 people weren't collected in a random way. So yeah, so definitely that's not one of them. Okay. Also, the question was kind of was like a leading question. The question was worded strangely to kind of the way it was worded. It might kind of bias the answers that people give. I felt like, but okay, but it wasn't random anyway. So okay, so next one, 10% condition. Yeah, so that's why they say it was a large audience. So those 100 people are less than 10%. We're assuming less than 10% of his large audience. You'd think a radio talk show with a large audience has more than 1,000 people. Okay, so we'll say the 10% condition is met. All right, and then law of large counts. There's two ways to do it. The standard way is n times p and n times 1 minus p. If you look at each of those has to be greater than or equal to 10. Also, all these this is the number of successes and number of failures from the sample. And so you can see there were 70 that voted yes and 30 that voted no, and that's what these would end up being. So you could do, like if you did n times p, so n is 100, and the proportion that answered yes is 0.7, and so that's how you get 70. And then the proportion that answered no would be 0.3, and that's how you get 30. But notice all these are number of successes and number of failures. Okay, and those are both these are both greater than or equal to 10, and so large law counts is met. So that's going to be A. Okay, number 2, they say a marketing assistant for a technology firm plans to randomly select 1,000 customers to estimate the proportion who are satisfied with the firm's performance. Okay, based on the results of the survey, the assistant will construct a 95% confidence interval for the proportion of all customers who are satisfied. Okay, the marketing manager, however, says that the firm can afford to survey only 250 customers. How will this decrease the sample size? How will this decrease in sample size affect the margin of error? Okay, so so the marketing firm wants to select 1,000 people for the for the survey, kind of, I guess. Yeah, but they can only sample 250 people because they don't have enough resources to sample 1,000 people. Maybe. Okay, so let's look how the sample size affects the margin of error. All right, so this is first off a margin of error for a proportion. So let's look at the margin of error proportion. So it's going to be whatever the z-score is based on the 95% confidence interval, z star, and this is for 95% confidence interval. So whatever that is, I'll just say, so we don't have to find that for this one, but okay, and then we'll times that by the standard error. So remember the standard error for a proportion is p hat times 1 minus p hat all over n. Okay, so this is the margin of error. Okay, so if we calculate the margin of error for each sample size, everything's going to be the same. The z-score is going to be the same. P hat, 1 minus p hat is going to be the same. So the only thing that's changing is this root n down here. So think about the, let's say for the 1,000, let's say if n is 1,000. Okay, so our margin of error is going to be whatever the z, whatever the critical value is for 95%. It's going to be over 1,000. Okay, another way to write this, we could say this is z star times square root of p hat times 1 minus p hat, so just kind of doing some algebra, divided by the square root of 1,000. Okay, and then let's do the same thing for 250 people. Let's say there's 250. So you're going to do the same thing. Z star. Okay, but then you could rewrite it just like we did the other one. Okay, so think about it. Each of these are margin of errors for each of those sample sizes. Okay, so think about, and remember the question says, how will this decrease in sample size? If we decrease the sample size, how will it affect the margin of error? Okay, so whatever, this margin of error is based on you, everything else is the same, but it's based on you dividing, you know, the z star times this square root of p hat times 1 minus p hat. You're kind of just dividing that by square root of 1,000. And the square root of 1,000, you could say, is 10 root 10. Okay, so that's what you're dividing by. You're dividing by 10 root 10 when there's a sample size of 1,000. Okay, when there's a sample size of 250, so square root of 250 is 5 root 10. Okay, so think about you're dividing by something that's twice as big as when the sample size is 1,000, you're dividing by 10 root 10, and when the sample size is 250, you're only dividing by 5 root 10. Okay, so think about you're dividing when the sample size is 250, you're dividing by a smaller number. So you're going to get a bigger margin of error. You know, when you divide by a smaller number, you know, assuming it's positive, if you divide by a smaller number, the overall fraction is going to be bigger. Okay, and if you divide by something that's half as big, right? 5 root 10 is half as big as 10 root 10. You're going to get something that's twice as big, and so that's why it's b. The margin of error will be about 2 times larger, just because you're dividing by something smaller, something half as big, so it's going to get bigger by doubled. Okay, so I'm not going to actually do the calculator or show it in this when I'm showing this problem, but you would use your calculator for this, but I'll just do this by hand. Okay, so they say confidence interval for a difference in proportions is negative 0.077 to 0.013. What are the point estimate and margin of error for this interval? Okay, so the first number in the answer choice is the point estimate, and the second number is the margin of error. Okay. Okay, so if you have your confidence interval, just in general, and it goes from A to B, the point estimate is the average. So I'll do B plus A over 2. Okay, so for this one, you'll do 0.013 plus a negative 0.077, which is really just minus, and then divide by 2. So if you do that, you get negative 0.032. Okay, so that's the point estimate. Okay, margin of error. Almost the same thing, but it's B minus A over 2. So we'll do almost the same thing, 0.013 minus a negative 0.077 over 2. And that ends up being 0.045. Okay, and that's it. So if you're given the interval, these are the endpoints of the interval. Just find the average, and that's going to be your point estimate. That's going to be the number. Point estimate's right in the middle. And then for margin of error, subtract the endpoints and divide by 2. So remember, the margin of error is always half the interval length. So do B minus A to get the interval length, and then divide by 2 because margin of error is half that. Okay, so that's answer choice A. Okay, number 6 for multiple choice. They say in a random sample of 100 students from a large high school, 37 regularly bring a reusable water bottle from home. Okay, which of the following gives the correct value and interpretation of the standard error of the sample proportion? Okay, so let's just do it. We'll do it by hand, and then we'll find the answer choice that instead of going through the answer choices one by one. Okay, they say find interpret this gives the correct value and interpretation of the standard error. So we want the standard error. Okay, so standard error in general for p hat is going to be this, just like the standard deviation for p, but with p hats. So this will be p hat times 1 minus p hat all over n. Okay, so for us, they say 37 out of the 100. 37 out of the 100 bring water bottles regularly to school. So p hat's going to be 0.37. Okay. And then the sample size was 100. Okay, so you can just type that into your calculator, and it ends up being 0.048. Okay. Okay, so we know it's the answer choices are either B or D. Those are the only ones that had 0.48 as the standard error at all. Okay, the other one had this 0.95 and 0.095, but both had those 0.0985 or 0.095, but that's not right. Okay, so Now let's look at B and D. So B says in a sample size, so we were trying to interpret this standard error. So in a sample size of 100 from this school, the sample proportion of students who bring a reusable water bottle from home will be at most 0.048 from the true proportion. No, that's not what standard deviation says. Standard deviation isn't the greatest value, the greatest proportion of students or greatest proportion of your sample or whatever, or your population. So let's look at D. So D says in a sample size of 100 from the school, the sample proportion of students who bring reusable water bottles from home typically varies by about 0.048 from the true proportion. Yeah, that's how we interpret standard deviation, talking about how it typically varies from the mean or from the true parameter, really. Okay, so that's D. Okay, seven's a good one. There's a couple kind of different things that happen, and then we have to do some algebra to solve a little equation or inequality. Okay, so they say many television viewers express doubts about the validity of certain commercials. In an attempt to answer their critics, Timex Group USA wishes to estimate the true proportion P of all consumers who believe what is shown in Timex television commercials. Which of the following is the smallest number of consumers that Timex can survey to guarantee a margin of error of 0.05 or less at a 95% confidence interval? Okay, so let's set up a little inequality that says that we want the margin of error to be 0.05 or less. Okay, so first off, just in general, we want the margin of error to be less than or equal to 0.05. Okay, so this is a margin of error for proportions. So with proportions, there's a z star that we have to find, do an inverse norm, and then we'll times this by the standard error. Okay, and we're trying to figure out the sample size, which of the following is the smallest number of consumers, they say in the question. So that Timex can survey, so that's n, that's the sample size that they're asking about. So the one thing is we don't have a sample that, they haven't even taken a sample at all to get a p hat. Here, what goes in here is p hat times 1 minus p hat, but p hat comes from a sample that someone take, but they never took a sample. Okay, so if there's no p hat, then we just use 0.5 for p hat, and that's called the most conservative estimate. Okay. So all that does is it makes the margin of error the widest possible, using p hat to be 0.5. Yeah, so it's called a conservative estimate for p hat. Okay, so first thing is to actually find z star. That's just doing inverse norm, and if you do inverse norm, either center when you do inverse norm for this one. So you either have two options for when you do inverse norm. If your calculator has the left, right, center, then you'll select center, and then just do 0.99 for 99%, so that's kind of easy. If your calculator doesn't have that option, then do left, and then all the area to the left, so if you have a thing, so that's the z star that you want. So if this is 0.99 in between z star and negative z star, then the area to the left will include this 0.99, but will also include this little area here. Okay, and so technically, you know, if this is 99%, there'll be 1% combined on these. So really 0.5% on each. So in this little area will be 0.5%. And 1% is 0.01, so 0.5% is 0.005. Okay, so if you just add these two together, you get 0.995. Okay, so when you do an inverse norm, you either do center with 0.99 or left with 0.995 if you want a 99% confidence interval. Okay, so it just depends on your calculator which way you do it. Okay, so if you do z star, I'm just going to kind of do it without showing it in the calculator. So z star ends up being, for 99% confidence interval, 2.576. Okay, and then this top is just 0.5 times 0.5. Okay, 0.5 times 0.5 is 0.25. Okay, and we want this to be less than or equal to 0.05. Less than or equal to 0.05. Okay, so we got to solve for this value of n. Okay, so we can do it different ways. I'm going to do it a certain way. So I'm going to first multiply by this, or divide by that, sorry. So this square root over 2.576. Okay, then we'll square both sides. Squared, that gets rid of the square root. Okay, and then I'm going to do a little thing where, just know this little math trick. If you have a fraction that equals something, or is, in this case is could either equal or it could be less than or equal to something, you can switch the denominator with the thing on the other side, as long as things are positive, which they are in this case. So you could say a over c is less than or equal to b. Okay, so these mean the same thing. And notice all you're doing is switching b and c to get that. So that's what I'm going to do. So I'm going to switch this and this. Okay, so if you do that, you end up with 0.25 all over that big thing squared. It's less than or equal to n. Okay, so if you do this in the calculator, you end up with 66 or 663.576. Okay, so this is saying n is greater than this number, and the least value out of all these, so n has to be at least this in order to have the margin of error that we want. In order to have at least, or at most, a 0.05 margin of error, n has to be at least this, and the least value from the answer choices that are greater than or equal to that is 700. Okay, that's how they got D. Okay, next one, they say the weights in pounds of 3 adult males is 160, 215, and 195, and they ask what's the standard error of the mean of these data. Okay, so first off, they want the standard error for mean. For a mean, and so standard error for a mean from a sample is the sample standard deviation whatever that is, divided by the square root of the sample size. Okay, we know the sample size is 3, so that's going to be something divided by root 3. And then the way to get the sample standard deviation is just to put everything in L1 and then calculate one variable stats. Okay, so just a reminder. So to enter in the data, go to stat, hit the stat button, your calculator, and then just hit enter for edit. Okay, and then edit into L1. And then once you do that, hit stat again. So that's just entering in data. Now to calculate things, hit stat. Go over to the calc tab, hit right. And then just hit enter for, it'll say one variable stats. So just hit enter. Okay, for the list, you make that L1. The frequency list, leave blank. Okay, just leave that blank and then go down and hit calculate. Okay, and you'll always use for us, you know, in there they have S of X equals, and then they have the population standard deviation equals, and so we'll never use this one. We'll use S of X, and so for us, S of X is 27.839, let's say. Okay, and then we'll go back up to the problem. That was S of X, so now we can put that in our fraction. Okay, calculate that, and that ends up being 16.07, and so that's it. That's the standard error for this set of just 3 entries, 3 pieces of data, whatever you want to call it. Okay, so that's D again. Okay, number 9, they say you want to compute a 90% confidence interval for the mean difference in height for mothers and their adult daughters who use a random sample, using a random sample of 30 mothers who have an adult daughter. Okay, what critical value should you use for this interval? Okay, so the only thing that really matters for this is that we're dealing with mean, you say mean difference. Okay, so we know that for means will be the critical value we're finding is T star. And when you're finding T star in the calculator, that's inverse T. Okay, and so we have to know that. And then the fact that it's a 90% confidence interval. So so when you do inverse T, they ask you for area and degrees of freedom. Okay, and so the area that you use is always to the left of the T value. So you can do this. So this is a 90% confidence interval, so 0.9 is going to be in between T star and negative T star. Okay, so but all you do is you'll do 1 minus the confidence level divided by 2. So 1 minus 0.9 is 0.1. 0.1 divided by 2 is 0.05. And so that's this little area is 0.05. Okay, and then whatever you get for that, just add your confidence level in that little area, add those together. So 0.05 plus 0.9 is just 0.95, and so that's your area. Okay, and then degrees of freedom. So degrees of freedom for these problems, at least for us. This isn't true always, but for these problems. Degrees of freedom is n minus 1 and n's the sample size. And so for us, the sample size was 30, so degrees of freedom will be 29. Okay, and that's it. And then just do, go to inverse t, do second vars, and then go down to number 4. That's inverse t, and then enter in 0.95 and 29 for area degrees of freedom, and it gives you the t value. T ends up being 0.699 or 1.699. So that's that. Okay, number 12. They say, which of the following is the critical value for calculating a 94% confidence interval for a population proportion? Okay, so the only two things that matter is the confidence level is 94%, and then to know that this is for a proportion, and so we'll do, to find the critical value, we'll do inverse norm. Okay, for if it's a proportion. Okay, and then just remember, if you're doing, if you're trying to find the critical value for a proportion, you do an inverse norm. When you go to inverse norm, if you have a calculator that has center, okay, and when you're doing these, you always do mu, make the mean 0 and the standard deviation 1. And then, let me see something real quick. Yeah, and then when they ask for area, that's really the first thing they ask for, but if you're doing center, just use the area as the actual confidence level. You don't have to do any work for that. But if you don't have that option, then it's assumed left. Okay, so you have to calculate it. Okay, and we'll do it just like we did the last one. So just think of a little normal distribution. You could just memorize a formula too. You can 0.94 is in the middle. We're trying to find the z star. 0.94 is in between negative z star and z star. Okay, so if you do 1 minus 0.94 divided by 2, that gives you this little area here. And that's 0.06 divided by 2, that's 0.03. Right, and then just add these two together. Okay, so we'll do, so in this case, the area, if you're going to the left, will be 0.97. Okay, so either way, depending on your calculator, either way, when you do that, you end up with a critical value that is 1.881. Okay, so that's C. Okay, number 13, they say a Census Bureau report on the income of Americans says that with 90% confidence, the median income of all U.S. households in a recent year was $57,005 with a margin of error of $742. Which of the following is the most appropriate conclusion? Okay, so, and I think all of these are kind of interpreting the confidence interval. When they have all these answer choices that have 57,005 would be the point estimate, and then this is plus or minus the margin of error. That gives the confidence interval. And so it seems like all of these answer choices are interpreting the confidence interval. So, so let's go through these one by one to see why the wrong answer choices are wrong and why the right one's right. So they say for A, 90% of all households had incomes in the interval between that and that. No. So the confidence level isn't the percent of the population that's in between or that's in the interval. That's just not what that means. Okay, for B, it says we can be sure that the median income for all households in the country lies in the interval. No, that's not how the interval works. It's not the values that you can be sure of. So, part C, 90% of the households in the sample interviewed in the Census Bureau had incomes that were in the interval. No, kind of like part A. The confidence level isn't the percent of the sample that's in the interval. So, okay, let's skip ahead to E. E says 90% of all possible samples of this same size would result in a sample median that falls within that of that. Okay, yeah, so yeah, 90% of all possible samples. Sorry, I got distracted. I can't remember if I said this already, but of the same size would result in a sample median that falls in there. No, 90% of all confidence intervals would capture the true proportion, but you can't say 90% of all samples would result in a sample median that falls within there. It's a slightly different idea. Okay, but answer choice D, they say the Census Bureau got the result of that confidence interval using a method that will capture the true median income 90% of the time. And that's what it is. It's the confidence interval. You know, if you do that for a bunch of samples, the confidence interval will capture the true median income 90% of the time, whatever that confidence level is. Okay. Okay, so that's answer choice D. Okay, last multiple choice question. They say the makers of a specialty brand of bottled water claim that their mini bottles contain 8 ounces of water. To investigate this claim, a consumer advocate randomly selected a sample of 10 bottles and carefully measured the amount of water in each bottle. Okay, the mean volume, so dealing with means, mean volume was 9.78 ounces, and the 95% confidence interval for the true mean volume is 7.93 to 8.03 ounces. Okay, based on the sample, which of the following conclusion best addresses the maker's claim? Okay, so before we look at the answer choices, let's just look at this. So the claim, or the 95% confidence interval. Oops. So if we look at that 95% confidence interval was from 7.93 to 8.03. Okay, so remember, these are considered all of the plausible values based on this confidence level. Based on a 95% confidence level, these are all the plausible values. So think about 8. So the claim was 8, and 8 does lie in this interval. Okay, and that's the most important thing. Okay, so let's see. So I think the most important thing is that the claim lies within the confidence interval, but it seems weird, but just know that it's not the only value, right? There's an infinite number of values in this confidence interval, and these are all plausible values. 8 is just one of them. 8.01, 7.99, these are all plausible values along with 8. So 8's just one of the plausible values out of an infinite number of plausible values in this interval. Okay, so let's read the answer choices. We'll go one by one again. So they say because 7.98 is in the interval, there is convincing evidence that their claim is correct. No, so really A and B don't even make sense because they're talking about 7.98, which isn't the claim. The claim is 8. Yeah, so these kind of don't even make sense to talk about. 7.98 was is the point estimate from the sample. So, and then the same thing with E. We're not talking. We're using the claim, the value from the claim, which is 8 ounces. So E doesn't make sense. Okay, so for part C, or for answer choice C, they say because 8 is in the interval, there's convincing evidence that their claim is correct. So no, that doesn't work that way. Because, so, let's say, yeah, so no, if there's not convincing evidence that their claim is correct because there's an infinite number of other values besides 8 that are in this interval. So that's not convincing evidence because there's, if that was true, there'd be convincing evidence for an infinite number of values, really. It's kind of a weird concept, I think, but okay, for part D, that's the answer. They say because 8 is in the interval, there is not convincing evidence that their claim is incorrect. So slightly different. You know, C says that there is convincing evidence that their claim is correct, and part D says that there's not convincing evidence that their claim is incorrect. So it almost seems like the same thing, but it's still slightly different. So the fact that 8 is in the interval, it just means that we can't say that they're incorrect. A lot of times we're trying to disprove the claim, and we can kind of find convincing evidence against the claim, but we can't find convincing evidence for the claim if the claim is a single value. So, okay, so that's why answer choice D is right. There's not convincing evidence that their claim is incorrect. And that's any time that the value, if there is a single value, is within the confidence interval. It's really the same thing every time. Okay, actually I'm going to skip the first free response. I feel like the answer key kind of answers that really well. But I'm going to do the other three since it involves a calculator, just so you can see how it works in the calculator mostly. Okay, so for the second FRQ, they say a milk processor monitors the number of bacteria per milliliter in raw milk received at the factory. Number of bacteria per milliliter. Okay, a random sample of 10 1 milliliter specimens of milk supplied by one producer gives the following data. Okay, so that must be the number of bacteria per milliliter of raw milk received by the factory. That's what those values are, number of bacteria. Okay. They say construct and interpret a 90% confidence interval for the population mean mu. Okay, I kind of want to do this one because just to see when they say construct and interpret a certain confidence interval, they mean to do state, plan, do, conclude. Okay, so you just have to know, they won't say do state, plan, do, conclude. They'll say construct and interpret a confidence interval, and this, you just have to know to do this. Okay, so let's do that one by one. So state. Okay, so we're just stating the confidence level and the parameter when you're doing this. Okay, so the confidence level is, what was it, 90%? So we're constructing a 90% confidence interval. Okay, but the real thing is that we want to include the confidence level. We have to know what confidence level this is happening at. And this is for mu, the true mean, the parameter, which equals the number of bacteria per milliliter, which equals the number of bacteria per milliliter of raw milk received at the factory. Okay, and this is just how they defined it in the question. Okay, plan. Okay, so when you're doing your plan is really kind of two things: stating the procedure, and our procedures are either going to be one sample t interval for p or for mu, or a one sample z interval for p. Okay, so for us, our procedure is a one sample t interval for mu, and that's what we're trying to estimate mu. Let's do that. One sample, since we're dealing with mu, it's like t star, so this is a t interval, they'll call it, for mu. Okay, and then we do the conditions. Okay, so so first off, random. Okay, in the problem, they say a random sample. Sample stated as random. Okay, and then we'll do the 10% condition. Okay, so so our sample size was 10, and 10 is less than 1/10 of all possible 1 milliliter specimens of milk. We'll just say the population. Okay, so that works out, and then the last one, so if we're doing, so if we're doing this for means, then the central limit theorem is, says that the sample has to be greater than or equal to 30, but that's not true, so that's not right. But you remember there are three possible things to show that it's normal. Remember that the law of large counts ultimately will prove that your distribution is roughly normal, so that you can use certain formulas, inverse norm or inverse t. Okay, so the central limit theorem is not satisfied, but if you look at the data, if you did a dot plot of the data doesn't have any huge outliers, or it's not skewed too far away from the mean, and so if the data is not, so this is really, this is a test for normality. So central limit theorem is not met, but you can say that there's no strong skewedness. I don't have that much room, and no outliers. I don't have that much room, but we really should show the dot plot to show that. Okay, put this over here. Actually, I'll keep this here. Okay, next thing, planned after plan is do. Okay, so now we'll actually construct that confidence interval. Okay, so first thing you'll do is, probably what I would do is go to stat and type all this into L1. Okay, and then when you do, you get x bar is 4,950. So that's the mean of this sample. And then you get the standard deviation. Oops. Is about 268.5. Okay, so And then also we know that our when we're calculating T star, we know that the degrees of freedom. Okay, so when we do inverse, actually we'll see when we do it. Yeah, degrees of freedom will be 9. Okay, always one less than the sample size, and then the area that we'll use is based on a 90% confidence interval. And so, the 90% confidence interval, we're doing this. Then there's 5% on each side, so we'll do 0.95 as the area to the left of the T star. Okay, so let's look at the calculator now. Okay, so go to edit. So I already put all that data in there into L1. So go back to stat. Go to one variable stats. So make sure the list is L1 and frequency list leave blank. Okay, so notice there's so notice our X bar 4950 here, and then whenever it'll always give SX and sigma X. That's sigma, lowercase sigma, and we'll always use the S of X, always the bigger one, and so that's how we got 268.5. So go back to blank screen, so I can quit. Okay, so let's now calculate our T star. So we'll do inverse T. Okay, we already know the area is going to be 0.95. We calculated that for a 90% confidence interval. And this is something to write down on your note card also if you want. Different confidence levels will always have the same area that you use. Okay, degrees of freedom 9. Okay, so that's our T star. So now when we're constructing our confidence interval, we'll do here. Let me move this a little bit. Okay, so our confidence interval will be X bar plus or minus. Actually, let me do this. I'll do the actual values. It'll be 44950, which is our point estimate, plus or minus that T star value, 1.833 times S of X divided by the square root of the sample size, which is that. Okay, so let's see. We'll do that in the calculator a certain way. Okay, I'm going to do the minus version first. We'll get the lower end of the interval first. So I'm just going to go up and grab that exact value and then times it by the fraction. Alpha, the button next to it, creates a fraction. And then just type that in. Okay, so that's the lower end of our interval, the left-hand endpoint of our interval. So just go up and highlight what we just typed in, and then all you have to do is change that plus to a minus. So that's really quick, so you don't have to type the whole thing over. And then that's it. Okay, so our confidence interval, we'll write that down. So confidence interval is 4794.356 to 5105.644. Okay, so that's the doing part. Everything in the do part is just working towards getting this confidence interval. The main thing. Okay, and then the last thing, oops, is the conclude part. Okay, and this is where you're concluding, you're interpreting the confidence interval. Interpret the confidence interval. Okay, and then that's in the answer key. They say we are 90% confident that the interval from blah 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 to blah 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 based on our confidence interval. Bacteria per milliliter captures mu, which is the true mean number of bacteria in the milk received at this factory. Okay, and that's in the answer key in Shobi. I'll leave that. Okay, third FRQ says a U.S. Forest Service is considering additional restrictions on the number of vehicles allowed to enter Yellowstone National Park. To assess public reaction, the service asks a random sample of 150 visitors if they favor the proposal. Of these, 89 said yes. Okay, so part A says construct and interpret a 99% confidence interval for the proportion of all visitors to Yellowstone who favor the restrictions. Okay, so whenever they say construct and interpret a confidence interval, we'll do state, plan, do, conclude. So let's do that. Part A, I'm gonna do it quickly, but y'all have to do it more when you're actually doing the test. Okay, so state. So first off, just stating basically the confidence level by saying it's a certain confidence interval. Okay, you say for, in this case, P, since we're doing a proportion, and then just state what the parameter is. P is the parameter, the true proportion. P equals the true proportion of all visitors to Yellowstone who would say that they favored the restrictions. Okay, so next one is plan. Okay, when you're doing your plan, say the procedure and show that the conditions are satisfied. So this is for a proportion. So this is a Z interval. So this is a 1 sample Z interval for P. That's the name of the procedure. So the 3 conditions are random. Okay, so do they say it in the problem? Yeah, they say a random sample. Sample stated, something like that. I don't know exactly. Okay, 10% condition. So they said the sample was 150. And this is definitely less than 1/10 of all Yellowstone visitors. Okay, so that's satisfied, and then the normal just has to satisfy the law of large counts, and the law of large counts, n times p would be 150 times the p hat ends up being 89 times 150. It's 150 times p hat. We'll do that in a little bit. But all that is number of successes, and that's 89. And then technically n times 1 minus p is number of failures, and just do 150 minus 89, and that's 61. Okay, and both of these are greater than 10, greater than or equal to 10. Should have put that for each of these. Okay, so law of large counts is met, 10% condition is met, and random is met. Okay, so all the conditions are met. Okay, so next thing we'll do the do part. So we'll do the do part in the calculator. Okay, so we'll go down here. So I think first thing we'll actually get a decimal for the point estimate. So that's just the 89 divided by 150. Okay, that's our point estimate. Okay, so let's now, if we're finding the margin of error, actually I'm going to store that. So that'll be the exact value. I'll store that as A. So A is our point estimate. Okay, next thing, let's find our confidence level. So we'll do inverse norm. Okay, this is a 99% confidence level, so the error is going to be 0.995. And we've done that a lot. And you can, at least for this test, you can write that on your answer key, but on your note card. Okay, always 0 and 1 for us. I know I'm going to do left, but if you do center, you'll just do 0.99. Okay, so that's our critical value. It's our Z star. Okay, so now I'm going to store that as B. Okay, so let's do our confidence interval now. I'll do the minus one first for the, as far as our plus and minus, so it's A minus. It's our point estimate. B, which is our Z star, times. Okay, we'll do the square root of P hat, which is A, times 1 minus P hat, so 1 minus A. And then all over the sample size, which is 150. Okay, so the A minus is the left-hand side of the confidence interval, so we'll grab it, change the minus to a plus, and that'll be the right end of our samples of our confidence interval. Okay. Put that over here. Okay, do. Okay, so first find P hat, 89 over 150. We found that to be 0.593. Okay. And then we'll do that, 0.593 plus minus. Our Z star was 2.576 times square root of our P hat, 0.593 times 1 minus 0.593, 150. Okay, and then that gave us that interval from 0.490 to 0.697. Confidence interval, kind of the whole thing that we're working towards, basically. Okay, and then again, the answer key will, the conclusion part will say we're 99% confident that the interval from 0.490 to 0.697 captures P, which is the true proportion of all visitors who would say that they favor the restrictions, something like that. All right, so that's all for just part A. So part B. So I'm gonna leave this for the just check the answer key. Okay, part B says, based on your work in part A, is there convincing evidence that more than half of all visitors to Yellowstone National Park favored the proposal? So more than half is more than 0.5. Okay, so so there is not convincing evidence. So they say, is there convincing evidence that more than half? So these are all the remember the confidence interval are all the plausible values. Okay, not all of the plausible values are greater than a half. So all the values from 0.49 to 0.5 are all plausible, very plausible values. So since not all of the plausible values are greater than this, then we can't say that there's convincing evidence that more than half, more than 0.5, of all visitors to Yellowstone National Park favor the proposal. If they said, is there convincing evidence that more than 48% of visitors favor this proposal? That would be yes, because all the plausible values are greater than 0.48. So there is convincing evidence that more than 48% of all visitors favor this proposal. So you could say that, but you can't say more than half. So you just say you can't conclude that more than half of all visitors favor the proposal. So, and there's not convincing evidence that more than half favor the proposal. Okay, last FRQ, last problem. They say, for some people, mistletoe is a symbol of romance. Mesquite trees, however, have no love for the parasitic plant that attaches itself and steals nutrients from the tree. Oh, okay. So there's trees, and I guess mistletoe is a parasitic plant that attaches itself to steal nutrients from the mesquite trees. Okay. To estimate the proportion of mesquite trees in a desert park that are infested with mistletoe, a random sample of mesquite trees was randomly selected. Okay, after inspecting the trees in the sample, the park supervisor calculated a 95% confidence interval of that 0.2247 to 0.5753. Okay, so notice they didn't give us the sample size, and that's really part B, is trying to calculate the sample size that was used to create the interval. So we're gonna, for part B, we're gonna have to work backwards. Okay, so, and I'm only gonna do part B. Part A is in the answer choice, or in the answer key in show B, and they'll interpret the confidence interval better than I would, so we're the same at least. Okay, so I'm just gonna do part B. Okay, and a lot of this is algebra, so they say calculate the sample size used to create this interval. Okay, so we really want to kind of set up an equation that involves the endpoints, or one endpoint of the confidence interval. So here, let's do this. So first thing is we want to I can't remember what I did in the calculator. Well, let's see. Here, sorry. Okay, so first thing is we'll find the point estimate. So let's go down to the calculator. Can't remember which way I did it. There's kind of two ways to do it. Yeah, so definitely get the point estimate first. So you'll find the average of the values in the endpoints of the interval. So that's just, these are just the endpoints in the interval. That's b plus a over 2. Okay, so that's our point estimate. Okay, let's get our margin of error now too. So margin of error is the same thing, but just changing it to minus. B minus a over 2, that's our margin of error. Okay. So now we'll go to, this dealt with means, so we'll do inverse norm to calculate the z star, the critical value. Okay, this is 95% confidence interval, so we'll use 0.975 is to the left. But remember, if you have this calculator that has this option, and if I was doing this problem, I would click center, but I'm just showing left works for both calculators, so I'm showing it for both. But if you have this calculator, just do center and 0.95, which is the actual confidence interval. You don't have to solve for anything and do left. Okay, so this will give us our z star value, 1.96. I'll store that as a, so I can use it. Okay, so let's go back to, we're gonna have to do stuff before we go back to the calculator. So let's set up our confidence interval. So it's gonna be our point estimate, which is 0.4 plus or minus our z star value, which is for us is a. Okay, and then times, so this is a proportion. So we'll do p hat, which is 0.4 times 1 minus p hat, which is 0.6 over n, and that's what we're trying to solve. All right, so we just have to really solve, and you know, what we could either say, so we could either say the plus of this, what the plus equals, or what the minus equals. I can't remember how I did it in the calculator now. Here, let me see. Just so I don't do it differently. Did I do this in the calculator? Oh, maybe not. Okay, but we'll do this by hand, and then you can just type it in the calculator. Okay, so you know this technically says plus or minus, but remember if we did the plus part, that'll equal the right hand side of the interval, and if we did the minus part, that would equal the left hand side. So I'm just going to do the plus part and set it equal to the right hand endpoint of the interval. So we'll change that to this plus or minus, just change that to a plus, and then we'll set this equal to the right hand side of the interval. Okay, so now we just start solving this for n. Remember, a is a number that from the calculator, that's the critical value, z star. Okay, so let's solve this for n. So divide both sides by 0.4. Okay. Yeah, divide both sides by 0.4, so you get a 0.4 times 0.6 over n equals 0.57. Oops. Divided by 0.4. So just divided both sides, or subtracting. What am I doing? Subtract 0.4. Okay, and then divide both sides by a. That'll cancel out that a. Technically divide both sides by a. Okay, and then we'll square both sides. Okay, squares and square roots cancel. Okay, let me write what we have left so far. So 0.4 times 0.6 over n equals that. Okay, and then I'm going to use the little trick where you can, if you have a fraction equal to something, you can like switch the denominator with the thing that the fraction equals. So if you do that, I'm going to move this again. If you do that, you get 0.4 times 0.6 divided by this whole thing squared. And then that equals n. Okay, so notice you have a fraction equal to something. If you want to solve for the denominator, you can switch this with the thing it equals, and notice I did that. So those switched for these here. All right, and if you plug that in the calculator, you end up with. Wait, let me see if I did that. I'm curious now. Oh yeah, I did that. Okay, so let's look down in the calculator again. Okay, so we'll have to do open parentheses and then put a fraction in there. What did I do? Okay, actually I subtracted them. So, 0.5753 minus zero point 0.4 is 0.1753. Divide that by that a that I found, and then squared it. Yeah, okay. So this gives the value for n. Okay, so that n is really 30. Okay, and that's like close enough to 30 that you'll either round up or round down, um, for a question like this. You won't round always, some questions you'll always round up, um, or always round down. This one you'll round just whatever number's closest, and so that's 30 is the closest. Okay, so a little bit of algebra when you want to solve for the sample size. Just have to set up your equation. I used the plus version, set it equal to the right hand side of the interval, and then now the rest is just solving this equation using algebra. Alright, that's it.